So word problem, a certain amount of chemical in one jug is 30% strong, and then it's combined with some chemical from another jug that's 25% strong, and it ends up being a 6-liter solution that is 28.75% strong. Okay, so we have 2 jugs, and then we combine them to get a final. That's kind of the idea, right? We have 2 jugs mixed. So when they talk about a chemical solution, do you understand what that means? So let's pretend this jug here is a chemical solution. Okay, so this is a chemical solution. Do you think this whole thing is chemical?
No.
No. Well, how do you think it was made? A mix of a little bit of chemical with water. So when they talk about 30% strong, it means 30% of this fluid is chemical and the rest is water. Okay, so if this was 1 liter, 0.3 of it would be chemical. Does that make sense, what chemical solutions are about? Okay, tell me what you want to name these jugs, which they're variables, right? Because we don't know. A and B. Okay, so here we go. The amount of fluid in A plus the amount of fluid in B equals 6. Okay, does that make sense? What was I doing there? The amount of fluid. There was something in A and something in B, and when I did put it together, it resulted in 6 liters, right? Okay, now let's talk about the amount of chemical. 30% of A is chemical. So 30% of A, that's how I write it. Does that make sense? 30% of A is chemical. Now what would the other one be? 25% of B is chemical. And what is the final jug chemical? 28.75% of 6, which I could actually just get as a number, right? So the chemical ended up being 1.725 liters of chemical in that final 6-liter jug container. But again, I didn't know how much chemical was in A or B. Okay, now we get to a point where we pick a method. Do you want to graph this? I don't want to graph it. Okay. Would you like to substitute? No. You can. But there's an easier method.
Why did you multiply by 6?
28.75% of the 6 liters is chemical at the end. So when you do that kind of math, it's timesing. You know what I mean? When you do a percent of something, you times it by the percent. No? I have to say it in a different way? How would you answer?
But isn't it 28% of the 6 liters?
Yeah. 28.75% of the 6 liters.
So why are we multiplying?
Because that's how you solve a percent of something. If I say your final grade, your final exam is 30% of your final grade, I'm timesing it by 30%. When you say a percent of something, it's a multiplication of.
I thought it was 6 What are you trying to figure out here? Like how much chemicals in the water?
How much chemicals inside jug A?
Per liter or?
Just how much chemical is in A?
Okay.
Or no, sorry, we're trying to figure out how much fluid is in A and how much fluid is in B.
Oh. Okay.
Yep. Okay. Elimination. Is everybody okay if I pick that? What do you want to do here?
Multiply 0.3 and 0.25 by 0.25. The second equation.
I'm going to multiply the second equation
Yeah.
by
0.25.
I want to multiply that one by 2.1. I don't think that gets me anywhere. I could do that to the first one. So let's multiply this by 0.25 then, if that's what you want to do. I'm going to multiply this top equation by 0.25. So 0.25a plus 0.25b equals 1.5. So we multiplied the top equation by 0.25, and then we left the second equation. Look at what we set up. We've set something up, now it looks the same. How do I get rid of them? Should I add or subtract the lines together? Subtract. So 0.25 minus 0.3 Okay, did you notice that those B's disappeared, right? Because that's the point. Elimination means you eliminate something. So one of the letters has to go. Okay, and now I'll divide. And I got 4.5, which is the liters of fluid in jug A.
Why'd you multiply the fluid 1 by 0.25?
This one?
Yeah.
Because to get the elimination, I have to make either the A's the same value or the B's the same value. So I could have multiplied this line by 0.3 to set up the A's to go away, right?
Okay.
But we picked 0.25 and then the B's would go. So it's, you look to say, how can I set these up so that I can make them, whatever letter I want to go, the same. Okay, now, how many liters of fluid are inside jug B? Where are you going to go to find that?
Subtract 6 with 4.5.
Yeah, so if this is 4.5, the whole thing needs to be 6. Can you do some mental math there? Jug B is full of 1.5 liters.
So 1.5 minus what?
It goes into this. So you would go 4.5 plus B equals 6. Right? Because you're going back to some kind of original with a substitution. Question 6. You have quarters and dimes. So those are our variables. Quarters and dimes. So those are the letters I'm going to use. Okay, you have twice as many quarters as dimes. I'm going to leave some space here. I'm going to write a 2 on one of those letters. How would you do it? You have twice as many quarters as you do the number of dimes that you have. So should I write 2Q equals D or Q equals 2D? I'm going to put them here for a visual. Which one of those math sentences would say I have twice as many quarters as dimes? I have twice as many quarters as I do dimes. What I would suggest is plug in a number.
2.
How many, do you think it's number 1 or number 2? Number 2.
That doesn't make sense.
Plug in a number for dimes. If you have 10 dimes, if you plug in a 10, how many quarters would you get? 20. 2 times the number of dimes you have makes the number of quarters. Does this make sense? Plug in a number, right? If you had 15 dimes and plugged that in, your quarters would end up as 30. You have twice as many quarters as you do the dimes. So your quarter equals doubled your dimes.
Why doesn't the first one work?
We'll plug in a number. So what do you want to plug in? So if you have 15 quarters, 2 times 15 would make 30 dimes. Does that make sense? So if I plugged in 2 times 15 quarters, now my dimes would be at 30. And that's not twice as many quarters. That's half the amount of quarters. Okay, next sentence. You have $15.60. So how do I do the money equation? We did this one last week on Friday. The money from the quarters. So 25 cents times each quarter plus the money from the dimes. 10 cents per dime equals $15.60. Okay, do you want to graph this? No. It's usually, graphing is usually not the best method. Substitute or eliminate? Substitute would be the strategy to go with here. Do you see that? So Q equals 2D. So now I can make a substitution, right? Do you see it? If I can replace that Q with a 2D. Okay, if I told you you had 9 quarters, how would you tell me how much money you have? What would you do mathematically? Yeah. What would your math be? If I said you have 9 quarters, how much money do you have? What would you do mathematically? But what would you do? Would you add, subtract, multiply, divide? What would you do? So if I told you you had 9 quarters, you should go, well, what's 9 times 25 cents? That's what I'm doing. That's why I'm doing 0.25 cube. Okay, so this would be 0.5D plus 0.1D equals 1560. And I could add that together. So this is 0.6 dime equals 1560. Divide and I get 26 dimes. When you're doing this, it should come out to whole numbers, or you might have done something wrong. You shouldn't get negative numbers, right? You can't have negative dimes. So how many quarters do I have? So I can say 26 dimes can go up here and get replaced. So 2 times 26 means I have 52 quarters then, because I have twice as many quarters. Okay? This is what I teach my applied class, because we read sentences like this. You have twice as many quarters. When you read it, you see the 2 with the quarter, right? But it actually goes on the opposite variable. I think that's what's confusing. The words, the twice on the quarters means the 2 actually goes on the other variable. It's a little bit like that. Yeah. Is that what you did? And then, yeah. But you get the same answer, yeah. Yeah, we did that last time just so we didn't have to work with decimals. Okay, number 7. So this is a physics question here. Your distance equals your velocity times your time. Okay? So a cyclist takes 3 hours to make a 51K trip while biking into the wind. The cyclist takes 2.04 hours to make a return trip with a tailwind. Find the speed of the bike and the wind. Okay, so I'm going to write this out. The velocity times the time equals the distance that we go. Okay, so let's take a look at the first sentence here. So we know it took me 3 hours. So I'm going to replace the time with a 3. We know that the distance was 51. So now, the velocity of the bike. What happens to your speed of your bike when you're biking into the wind? You go slower. So this is what I'm going to write. The bike speed subtract the wind speed. When you're biking, you're losing speed. When you're going into the wind, you're getting slower. You're losing speed. Does that make sense?
Yeah.
The wind is pushing against you. It's subtracting your biker's speed.
So why would you subtract it with the wind?
Because if you're pedaling, if you were to pedal without wind, let's say you're just going 10 kilometers an hour, but then there's a wind pushing you now at 2, now you're actually only traveling 8 kilometers an hour. Like if your legs can only go as fast as 10 kilometers an hour, but then the wind is coming at you, the wind slows you down, right?
Okay, so that would be 8 subtract 2 equals 6.
Yeah, but I don't know. These are the things I don't know. I don't know the bike speed and I don't know the wind speed.
But that is what you want to do.
Yeah, I want to subtract it. Okay, now let's talk about the return trip. So the cyclist on the way back takes 2.04 hours. So there's the time, 2.04 hours. To make the return trip, guess what the distance is? The same, because he's doing the same trip, but just on the way back. And this time, there's a tailwind. So that's on your back. So think about the wind behind you. It's going with you. So what happens to your bike speed? The wind will make you faster.
Okay, so that's the bike speed plus the wind speed.
The bike plus the wind. When it's a tailwind, you're going faster.
Yeah.
Yeah. Right? Does that make sense?
Yeah.
Okay, I'm going to now do distribution. I'm distributing, I said, like that. So I need you to multiply by 3. This whole bracket gets multiplied by 3.
Why is there 2 W's?
Yeah.
Whoops, this is supposed to be a B. Thank you. 3B minus 3W. Okay, everyone, that's just a distribution. Okay, I'm going to pick elimination. Do you see why I probably will do that? What's the setup? Think about how to set up your elimination. What are you going to do? I'm going to times this by 2.04, and I'm going to times this by 3. Everybody see why I would do that? Because I'm trying to make either the B's or the W's be the same value. So I get 6.12B whoops, I got to multiply 51. This is a common mistake, and I just did it. 51 times 2.04.
You're not multiplying both of them. You're just choosing one to multiply by the opposite.
Yeah, like so if you ever had a 2a in one equation and a 5a in another equation, you would probably multiply this one by 5 and this one by 2 so that you're setting yourself up that they would both be a 10, right? And then you eliminate them. Okay, there's basically 2 choices here. What do we want to attack? Do you want to attack the B's or the W's? Okay, so you're picking W. If I want to get rid of those W's, would you add or subtract? Add. So 12.24B. That's W gone. $257.04. Okay, and then I divided and I got 21 is the bike speed. So that's in kilometers per hour because it's a speed of the bicycle.
Is this on the first trip or the last trip?
Doesn't both trips. You're always, the biker itself is always going the same bike speed. Like you're always pedaling the same speed. It's just that the wind makes you either travel faster or slower. So you're consistently biking, right? So what is the wind speed? Where are you going to go to put that in? You got to plug it into one of these. I'm going to pick, the first one looks a little bit easier. So 20,
So,
or I could plug it in here too, I guess.
the very last step you divided by 12.
Yeah, I divided by 12.24. Okay, so I'm plugging 21 in. So I plugged 21 in. I'm going to divide by 3. Can you answer that with just mental math right now? What is the wind speed? 21 minus what? What makes sense to you in real world? 21 minus what makes 17? 4. the wind speed is 4 kilometers per hour. Does that make sense in the real world? Sometimes I get people who answer me negative. So understand, like, that doesn't make sense in the real world. If you have something like 200 kilometers an hour, probably not making sense unless it's literally a tornado happening while you're biking. I'm not sure if that would make sense, right?
But it can be negative.
A wind speed can't be negative.
It can be in physics, you know, that it can be, because you're basically moving backwards.
That's not speed. That is like velocity, yeah, but not speed.
So wait, if you're going like 10 kilometers an hour biking,
Mm-hmm.
and you have a tail, like, and you have there's a tailwind of, let's say, 20 kilometers an hour, that's not going to make you bike 30 kilometers an hour.
Okay. This case, so my bicycle, my legs were moving at 21 kilometers an hour, right? When I had a tailwind, it actually made me travel 25 clicks an hour. But when I had that headwind, I was only going 17 kilometers an hour as a speed. Have anybody ever been on an airplane?
Yeah.
Have you ever heard the pilot come onto the radio and was like, oh, we had a nice tailwind today, we're going to arrive half hour earlier than expected? Anybody ever had those situations? Because the wind is blowing, helping the airplane go faster than it could. It's a tailwind. Obviously, if there's a headwind, lots of times the airplanes arrive actually later than expected, right?
Yeah, but in your 21's PRW times 3 equals 51, you're dividing just the 3, or you're dividing over the rest?
I'm dividing the whole side, which makes that happen.
Okay, wouldn't you divide 21 by 3 then?
No, because this is 1 unit. So it only has to get divided by 3, the whole unit, which makes the 3 cancel. When math is connected with, it'd be like me doing this, 3x divided by 3. I don't divide the 3 and the x by 3, I just say 3x divided by 3. Right? That's the same idea as that, because you're multiplying 2 things and dividing by 3. You're thinking more the lines like this. If I separated terms like this, Moses, if this was divided by 3, then I would have to do that separately. But in math, when you have this unit times this unit, it's glued together as 1 unit. So you only have to divide it by 3, the whole unit, once. Just like how 3x is treated as 1 unit divided by 3. Okay, the last question is the same as number 5. Class A is 50% girls, Class B is 60% girls. When I combine the 2 classes, the result of the combined class of 56 students is 55.36% girls. So let's talk about the students. So A is the number of students in Class A plus how many students are in Class B makes 56 students. The girls, so this is like the chemical question. 50% of Class A is girls. So 50% of A is girls. That's how I do the math. 50% of something. Plus 60% of Class B is girls. When they got combined together, 55.36% of the total 56 was girls? And I am going to just times that. There's 31 girls. So in the 56, 31 out of the 56 were girls. Yeah, yeah, because it came to like that, but it's because I had to round something in the question there. Okay. What do you want to do? Graph, substitute, or eliminate? I'm going to eliminate. What do you want to match up here? Do you want to make these A's the same or these B's the same? A. So I'm going to times the whole line by 0.5. So 0.5A plus 0.5B equals 28. So we matched the A's to be the same. So how do you want to get them out of there? Do you want to add them together or subtract them? How would they disappear if you added those numbers or subtracted those numbers? Subtract, gone. Okay, carry out your algebra. Move, divide if you need to, right?
Why is there two equations?
There's always two equations because it's.
Yeah, okay, where did you get the first one?
The first one is how many students in A plus however many students in B make 56 students together. Does that make sense? This is A is the number of students in class A. That's what that A means. The number of kids in class A plus the number of kids in class B all together are 56 kids. Then I knew that 50% of all the A kids are girls and 60% of the B are girls. So this is the percent of those classes that are girls. Okay, we always plug in. So if class B is full of 30 students, class A would have 26.